So in this example, we want to do, you'll see we're going to have to do partial fractions. So let's just write it up properly first. We want to write it as a finite integral, so I want to put my t in there. By the way, it is tempting not to do that, I know, but you really should do that. It's the correct way of writing this thing. And once I do this, this is going to be x plus 3, x minus 1. Okay, so now I have to do partial fractions, right? So I have to do a little more work on this one. But this is an easy enough partial fractions, right? Because I've got 1 over x plus 3, x minus 1. So it's going to be a over x plus 3 plus b over x minus 1. So when I put this all together, I'm going to get this. Okay, so if I rewrite that, I got a plus b times x plus minus a plus 3b. Now you can see there's no x terms over here, so I'm going to have a plus b equals 0, and my next one minus a plus 3b equals 1. So super easy, right? Add these two, I get 4b equals 1, or b equals 1/4. And then since a plus b equals 0, that gives me a equals negative 1/4. So writing that back up here, I'm going to end up with these two integrals. Wait, a is the negative. And then, okay, so minus 1/4 2t dt over x plus 3 plus 1/4 2t. What's the other one? dx over x minus 1. Okay, so just making sure that all of my pluses and minuses are straight. Okay, I'm going to get rid of this so I have more space. You can see these are pretty straightforward. To integrate, it's just natural log. So I'm going to have minus 1/4 natural log of x plus 3 plus 1/4 natural log of x minus 1. Evaluate from 2 to t. Okay, so we're pretty used to just, and I'm usually fine with just leaving it. Oh, no, it's the extra 1/4 there. Fine. Sorry, good thing I noticed before I ended up with the wrong answer. So I've got, when I evaluate this, natural log of t plus 3 plus the 1/4 natural log of t minus 1, and then minus plus, at 2 I've got natural log of 5 minus natural log 2 minus 1 is 1. So this guy's 0. Okay, so when I take the limit of this, here's the thing, you have to be paying attention here, because natural log of infinity is going to be infinity, right? But I've got a negative here and a positive here, so what I would end up with, when I plug this in, is negative. It's basically infinity minus infinity, right? Minus infinity plus infinity, and this is an indeterminate form. We don't know if that's going to plus infinity, minus infinity, or 0. Like, we just don't know. So when you see, you have to be careful when you see infinity minus infinity. In this case, what we can do is bring these two together, because this natural log, right? So if I have natural log of x minus natural log of y, properties of logs is that that's natural log of x over y. And you can always do this. I know that the WebAssign often they'll just always simplify these that way. I usually don't bother because there's no reason to if it's just an ordinary problem. But now when we've got this limit, we really have to do that. We don't have a choice, because I can't figure out what this infinity minus infinity does. So this is going to be like this, t minus 1 and t plus 3, right? And in fact, t is always bigger than 2, so I no longer even need these absolute values if I really want to be. Notice that, right? So this is, all these things are positive. So regardless, plus 1/4 natural log of 5. Okay, now what happens to this limit? So that's not necessarily easy to see. Well, you have to do something. So I'm going to do it in the side here. A little bit of work is required because natural log is a continuous function. Sorry, I don't know how that became negative infinity. Goodness. Because natural log is a continuous function, I can take that in there. So as a limit as t goes to infinity of this thing, natural log of t minus 1 over t plus 3, okay, I can pull the limit in because of the continuity. And then I just have the limit of this guy, right, which is a rational function. So what do I do with a rational function? Limit of a rational function, I divide top and bottom by the highest power, right? So that would mean 1 over t and 1 over t. So I get 1/4 natural log, I'm stuck here, limit as t goes to infinity of 1 minus 1 over t and 1 plus 3 over t, right? So that's just going to be 1 as I take the limit because these guys go to 0. So this is 1/4 natural log of 1, which is just 0. So it turns out this limit, this infinity minus infinity, does go to 0. And the value of my integral is what's left over here, 1/4 natural log of 5, right? Okay. But you need to do a little bit of work to show that that limit goes to 0. All right. So I have one more example. This is an example which goes from negative infinity to infinity. We haven't had one of those yet. What was the integral? X e to the minus x squared. Oh, that's easy to integrate, yay. Okay, but we haven't had one of these yet, so I had to have one of these, right? Remember, when it's plus and minus infinity, we have to break it up in the middle, and we have to look at them as two separate limits because you don't want things to sort of end up canceling out when they shouldn't. Okay, so I am going to do limit as s goes to negative infinity of s to 0 of x e to the minus x squared plus the limit as t goes to positive infinity, 0 to t. Are those showing up? Yeah, good. I'm to make sure I'm not off the board for you guys. So I basically have two of these. Oh, lost a square, lost a square. Whoop. Sorry about that. Now both of the integrand is the same. So when I integrate it, it's going to be the same. But then I have to look at the limits separately, right? Because one is going to negative infinity, one is going to positive infinity, and I kind of have to think about them as maybe going at different rates. I don't know how fast they're going. I don't know what's going on. Right? So therefore, that's what I want to do. But these are simple U substitutions, right? U equals negative x squared, then du is minus 2x dx. So I get the minus x squared with a negative 1/2, right? So I got negative 1/2 e to the minus x squared, evaluate from s to 0, plus the limit as t goes to infinity of negative 1/2 e to the minus x squared, evaluate from 0 to t. Okay, so now what do I get? Well, I get minus 1/2 e to the 0 is 1 plus 1/2 e to the minus s squared. So there's that limit. And then my second one is going to be minus 1/2 e to the minus t squared minus and minus plus 1/2. Okay, so what's going to happen here? The important thing is that there's a minus here and it's s squared. So if it wasn't s squared, if it was s, we would have a different answer, right? Because that would matter whether you were going to negative infinity or positive infinity. It happens in this case that it's x squared. So whether s is negative or positive, the squared is going to kill that anyway. So if I look at this limit, the limit, I'm basically looking what's going on for e to the minus infinity, right? So this minus gets killed by the squared, so this just goes as e to the minus infinity. E to the minus infinity goes to 0. Same thing here. Yeah, sure, it's positive, so I've got e to the minus infinity. This guy goes to 0 as well. So my actual answer is minus 1/2 plus 1/2, which ends up being 0. The actual answer here is 0. Okay? And it is going to be 0 because you can think about this. This is actually going to be an odd function. It's got as much on the top on one side and on the bottom of the other side. So the area is going to cancel out, but it's going to be finite, so we can really say that it really cancels out. Okay? So that's the difference. That's the difference between something that is, I don't know exactly what this looks like, but it probably looks something like this, right? Versus something like this, right? This is just hopeless. You're obviously gonna have an infinite size underneath there. So saying that it cancels out isn't correct. Whereas here, you are going to have a finite area on each side, and that area is going to be the same.